Example 6a, we're evaluating another expression. I think this looks really super complicated. Okay? It looks really tough. But what's important to remember is that when you see an inverse trig function like this, that's an angle. And here's another inverse trig function, so that's going to be another angle. And so what I would do, what I would recommend that you do is just call this one something and call this one something else. And so what I've got there is two different angles, angle A and angle B. You could use theta and beta if you want. You could use Greek letters, I suppose, but probably going to be more familiar to you if you use A and B here. But I've got angle A and I've got angle B. And so if you look at what you have at this point, that should look familiar to you. You've got a cosine sum, and I see some of you looking at the formulas right now. That's smart, okay? This should remind you of one of those identities on the board right now. You've got a cosine sum. And so look at the cosine sum formula. Find the cosine sum formula. It says cosine of the first one, cosine of the second one, minus sine of the first one, sine of the second one. So we've seen this problem before. We've done this, I forget if this was section 7.3 maybe, but we had 4 holes to fill in. And that's what we're going to have to do. We're going to have to fill in those 4 holes and then simplify. Okay? But go back to what I've written in red there. We understand that an inverse tangent is an angle. So let's draw a picture of that angle. What you want to do is you want to remember where inverse tangent is defined, and that comes from the range. And so the range on an inverse tangent is from negative pi over 2 to positive pi over 2. In other words, yeah, you did. So we are in quadrants 1 and quadrant 4. Okay? Quadrant 1 and quadrant 4. And so when you look at this ratio, I know it doesn't look like a ratio, but square root of 3, we call that square root of 3 over 1. My ratio is a positive value. And the positive values are always going to be in the first quadrant. Okay? So when I see this, I see that positive value. I see it's going to be in the first quadrant. I'm going to draw a picture of that angle in the first quadrant. This is angle A. Make sure you label it. I'm seeing a lot of students that aren't labeling their angles. Make sure you label this. Okay? Tangent, inverse tangent, we know that the tangent ratio is y over x. So your square root of 3 over 1, let's label that y over x right there. And then we can do Pythagorean theorem to figure out the missing side. And at some point you're going to be able to do this in your head, I think, but we do 1 squared plus square root of 3 squared equals c squared r squared. That's 1 plus 3, that's 4. And so square root, we know that hypotenuse is going to be 2. That missing side is 2. All that was Pythagorean theorem. So once you've got all those sides, then you ought to be able to tell me any of the trig ratios. And you look at your 4 blanks that you have to fill in. It looks like we need to know what cosine A is. We need to know cosine A, and we need to know sine A. And you ought to be able to tell those from this picture. Look at the picture, look at the angle, look at the relationships to the sides. The cosine ratio, x over r, that's going to be 1/2. The sine ratio, y over r, is going to be square root of 3 over 2. And so I should be able to fill in those 2 spots based off of my picture. Okay? That's all I can tell about angle A, and so I can't fill in those other blanks. I'm going to need to draw a different picture of angle B. And so you look at arc sine. Arc sine, we want to know where to draw it. Remember the range for inverse sine there is this. But again, that's talking about quadrants 1 and quadrant 4. 1 if you're positive, 4 if you're negative. And so when I see that this 1/3 is positive, that's directing me towards that first quadrant. And so I'm going to draw a picture of angle B in that first quadrant. Again, label it. Arc sine 1/3. I've got the sine ratio is 1/3. That's y over r. So y over r, I've got those two sides, and I can find the missing side using Pythagorean theorem. I'm going to do x squared plus 1 squared equals 3 squared. That's x squared plus 1 equals 9. Subtracting, you get x squared equals 8. And so square root, we're looking at the square root of 8, plus or minus. Plus or minus. Okay? But over there on the right, first quadrant, we're talking about a positive x value, so that's going to be the square root of 8. Square root of 8 there. Okay? That's probably a good idea to simplify that square root. That's square root of 4 times square root of 2, or 2 square root of 2. Okay? So when you need the cosine ratio, cosine B right here, cosine is going to be x over r. We're going to call that 2 square root of 2 over 3. And then your sine ratio is y over r, that's 1/3. And so all that's left is I'm going to simplify my fractions and stuff. So I've got, over on the left here, 2 rad 2 over 6 minus square root of 3 over 6. I've got 2 radical 2 minus square root of 3 over 6. And that's it.